Hello YouTube family, welcome back, and let's provide the solution given this nice exponential equation, which is 7 raised power x plus 49 raised power x plus 343 raised power x is equal to 155. Okay, now solution from here, we have 7 raised power x plus 49 raised power x can be expressed as 7 raised power 2 raised power x plus 343 can also be expressed as 7 raised to power 3. So we can express this as 7 raised to power 3 raised to power x. This is equal to 155. Okay. Now from what we have here, applying the indices identity, if you have a raised to power n raised to power m, this can also be expressed as a raised to power m raised to power n. Okay. So let's apply this property so that we're going to have 7 raised to power x plus 7 raised to power x squared plus 7 raised to power x cubed. This is equal to 155. Okay. Now from here, we say let 7 raised to power x bm. Okay. Let 7 raised to power x bm. Let's substitute where we have 7 raised to power x with m. So we'll have m plus m squared plus m cubed. This is equal to 155. Okay. Now we have to take 155 on the left hand side so that we'll have m plus m squared plus m cubed subtract 155. This is equal to 0. Okay. So we have m plus m squared plus m cubed. Now we can express 155 as 5 plus 25 plus 125. This is equal to 0. All right. Now from what we have here, this is m plus m squared plus m cubed. Now this is subtract 5. Okay. Now from what we have here, we have negative times positive 25, which is the same as negative 25. Now 25 can be expressed as 5 squared. Okay. And then we have negative times positive 125. This can also be expressed as 5 cubed. 5 cubed is the same as 125. This is equal to 0. Okay. Now, let's combine this. We'll have m. We can say m subtract 5. Okay. Plus m squared. This m squared subtract 5 squared plus m cubed subtract 5 cubed. This is equal to 0. All right. Now we have got 3 parts here. This is the first part. We have the second part, and now we have the third part. Okay. Now, if you check the second part, this is actually the difference of two squares expressed as a squared minus b squared, which we can express as a plus b, a minus b. Okay. Now we have m squared subtract 5 squared. This is the same thing as m plus 5 m minus 5. Okay. Now for the third part, this is actually the difference of cubes, of two cubes, expressed as a cubed subtract b cubed, which is the same thing as a minus b, a squared plus ab plus b squared. Okay. Now from what we have here, we have m cubed subtract 5 cubed, which is m minus 5, m squared, okay, plus 5m plus 25. Yes, this is what we have. Let's combine the 3 parts. We have m minus 5, okay, plus m subtract 5, m plus 5, okay, plus we have m subtract 5, okay, into the bracket we have m squared plus we have 5m plus 25. This is equal to 0. Okay, so I can write this as m subtract 5, okay, plus this is m minus 5, the difference of two squares, m plus 5, then plus we have m minus 5, we have m squared plus 5m plus 25. This is equal to 0. Okay. Now, as you can see, m minus 5 is common, so we can factor out m minus 5 into the bracket. We'll have, this is 1 plus, this is 1 plus, this is m plus 5. Okay. Plus, now this is again m. We have m squared plus 5m plus 25. Close the bracket. This is equal to 0. Now we have two parts here, that is m minus 5 and whatever is in the parentheses. So we have m minus 5, this is equal to 0, and that means that I can call this m1 is equal to 5, okay, which is a real root. This is a real root. Now let's move to what we have in the parentheses. We have 1 plus, this is m plus 5 plus m squared plus 5m plus 25. This is equal to 0. Now let's form a quadratic equation from what we have here. We have m squared, okay, plus, now we have m plus 5m, and this is equal to 6m, plus, now we have 1 plus 5, 6, 6 plus 25, this is 31, which is equal to 0, okay. Now this is a quadratic equation, okay. This is a quadratic equation which is in the form of am squared plus bm plus c, this is equal to 0. Now, from the quadratic equation here, we have a equal to 1, b equal to 6, and c equal to 31, okay? Now, let's find the discriminant value so that we can be able to determine the nature of the root of this quadratic equation. Discriminant value is expressed as b squared minus 4ac. Okay, let's substitute the values of b squared. B squared is 6 squared, which is 36. Subtract 4 multiplied by 1 multiplied by 31. Okay. Discriminant value is expressed as b squared minus 4ac. Substituting the value of b, which is 6 squared, which is 36. Subtract 4 times 1 times c, which is actually 31. So this is the same thing as 36. Subtract, this is 124. And this gives us a value of negative 88, which is less than 0. And that means we have two complex roots. We have two complex roots in this case. Now, from this, we can be able to calculate the rest of values of m2 and m3 by applying the quadratic formula, which is m is equal to negative b plus or minus the square root of b squared minus 4ac, divide everything by 2a. Okay. Now let's substitute this. Now we have negative 6 plus or minus the square root of b squared minus 4ac. Now b squared minus 4ac is what we have here, which is negative 88. So we have negative 88 divided by 2. Okay. Now from what we have here, this is the same thing as negative 6 plus or minus. Now negative 88 can be expressed as 4 times 22 times negative 1 divided by 2. Okay. Now we have negative 6 plus or minus the square root of 4 times 22 times negative 1 divided by 2. Now this is the same thing as negative 6 divided by 2 plus or minus. Now the square root of 4, this is the same thing as 2. Okay. The square root of negative 1, this is I. And then we have the square root of 22 divided by 2. Okay. And this is equal to, now if you simplify here, this is the same thing as negative 3 plus or minus. Let's simplify here. This is the same thing as square root of 22i. Okay. So this is what we have as the complex roots. So that means that m2 is equal to negative 3 plus square root of 22i, and m3 This is the same thing as negative 3 subtract square root of 22i. Now, these two are complex roots. These are complex roots, or imaginary roots. These are complex roots or imaginary roots. And therefore, if we determine the logarithms, if we get the logarithm part of these complex roots, we will not get a defined solution. In other words, we get undefined solution. Okay, so we have only one real root, one real root or real solution, which is m1, which is equal to 5. Okay, so applying this m1, which is equal to 5, if you recall, we insane that rate 7 raised to power x be equal to m. Okay, so we'll have 7 raised to power x, this is equal to m, which is 5. Okay, now to solve for the value of x, we introduce the natural logarithm, so that we're going to have log 7 raised to power x, this is equal to log 5. We apply the logarithm on both sides. Okay, so that now log 7 raised to power x, this is actually in the form of log m raised to power n, which you can express as n log m. Okay, this is the power rule property of logarithms. So let's apply this power rule property, so that we'll have x log 7, this is equal to log 5. Okay, you recall we are saying that let 7 raised to power x be m. Substituting the value of m, we'll have 7 raised to power x, this is equal to 5. Now to solve for the value of x, we introduce the natural logarithm, so that we'll have log 7 raised to power x, this is equal to log 5. Okay, we apply logarithm on both sides, and you find that log 7 raised to power x, this is actually in the form of log m raised to power n, which can be expressed as n log m. Okay, so applying this logarithm property, you will have x log 7, this is equal to log 5. Okay, so we divide both sides by log 7 and log 7. Okay, so that's from what we have here, log 5 divided by log 7, this is in the form of log a divided by log b, which we can express as log a to base b. So let's apply this property, so that the value of x is equal to log 5 to base 7. Now this is the value of x. Okay, this is the value of x. So let's verify, or let's check if this value of x actually satisfies the equation. Okay, remember that we end the equation, we end that 7 raised to power x plus 49 raised to power x plus 343 raised to power x. This should give us a value of 155. Okay, now substituting the value of x, we'll have 7 raised to power log 5 to base 7 plus, this is 49 raised to power log 5 to base 7 plus, this is 343 raised to power log 5 to base 7. This should give us a value of 155. Okay, now this is 7 raised to power log 5 to base 7, and this is actually in the form of m raised to power log a to base m, which is basically equal to a. Okay, applying this logarithm property, this follows us. So let's check if this value of x, which is log 5 to base 7, actually satisfies the equation. So as you might recall, we end that 7 raised to power x plus 49 raised to power x plus 343 raised to power x is equal to 155. Okay, so let's substitute this. We have 7 raised to power, this is log 5 to base 7 plus 49 raised to power, this is log 5 to base 7 plus 343 raised to power log 5 to base 7. This should give us, let's check if this is supposed to give us this value of 155. Okay, now 7 raised to power log 5 to base 7, and 49 raised to the power of 5 to be 7, as well as 343 raised to the power of 5 to be 7. This is in the form of m raised to the power log a to base m, which you can express as a. Okay, so let's apply this logarithm property so that we'll have 7. This is 7 raised to the power log 5 to base 7, which is basically equal to 5. Okay, now we have 49 raised to the power log 5 to base 7. Now remember, we can express 49 as 7 raised to the power 2 log 5 to base 7, and this is the same thing as 7 raised to the power log, this is 5 squared, okay, which is the same thing as 25 to base 7. So this is equal to 25. Okay, now let's check 343. We have 343 raised to the power log 5 to base 7. Now this can be expressed as, now this is the same thing as 7 raised to the power log 5 cubed to base 7, and this is equal to 5 cubed. Okay, now let's substitute this. This is the same thing as the first one. You have 5 plus we have 25 plus 5 cubed. This is 5 cubed, which is 125. This should give us a value of 155. Okay, so 5 plus 25, this is 30. 30 plus 125, this is equal to 155, which happens to be equal to 155. So the left hand side is equal to the right hand side. Okay, and that shows that the value of x, or that's as that shows that the value of x, which is log 5 to be 7, actually satisfies the equation. Okay, so follow the steps and kindly subscribe and like this video. Okay, see you in the next video.